Hello everybody. In this video, we're going to talk about some applications of gradients. So this is still from section 14.5 and we are going to talk about how to compute an equation of a line which will be tangent line, and also we would ask how to find an equation of a normal line. So we first need to be clear with what we mean by those tangent line and normal lines to a curve, given curve f of xy equals c. So f of xy equals c. This is just 2D. So there are two variables, x and y. If you think of y as x function, then this is implicit function, which is living in 2D surface. It's not a 3D surface. So if you put the graph, then it is living in some shape of 2D. And you can think of this as f of xy equals c. The question about tangent line is, suppose you are sitting here on the curve, then the tangent line is the line just going through the point just at one point, at that point. This is a tangent line. And normal line is the line perpendicular to tangent line. Okay? So we're going to ask equation of tangent line and normal line. So to find an equation of a certain line, usually there's one way to find. So we need a couple of information for a line equation. For tangent line, if we look at this problem, we already know the current point, which is x0, y0. So this is given information. The only thing you need to know is the slope or the direction of tangent line. And also the same thing for normal line. For the normal line, you already have one point on the line. And then, as long as you know the slope or direction of this normal line, then you're done. All right. This problem is entirely a problem to the calculus 1 because this is a two-dimensional question. So we can use implicit rule to solve this problem and find tangent line and normal line, respectively. But by putting this problem here, we're going to use multivariable calculus to simplify the question. So how we do that? So the idea is following. We can think of this curve as a level set curve. So this curve as a level set curve of 3D mountain or 3D valley. So by saying that, we can imagine this. So a contour map. So when these curves shrinks to a point, it goes to a valley, a bottom of the surface. And if it's expand, then the level set is increasing its height. Then what about the interpretation of this curve f of xy equals c? This is level set of entire surface at the level c. C is the level of this curve. And the whole surface, 3D surface, is z equals f of xy. Then in the previous section, we've talked about the gradient, and we also talk about when you're moving to gradient direction, then you're moving to the top of the mountain as fast as you can in the fastest route, which exactly the normal line. So the normal line has the same direction as gradient f. And if you want to maintain your height, or you want to hike at the same level, then the direction is supposed to be perpendicular to this gradient f. So the direction is gonna be, we can simply write this as gradient f and perpendicular. So slope is the direction, and if you know this or know this, then these are enough to find equation of lines, given that it already has given points. So using this information, we can write down the formula. So what is normal line? Normal line is the line going through your position with the slope or with the direction to the gradient. So normal line is through x0, y0, and direction gradient f, which is fx, fy. Then to find this kind of line, suppose if I have x0, y0, right? And I want to find the line which is in the direction of given vector fx, fy. Then for this, any point xy on this line, the slope is change in y and change divided by change in x, which is giving a slope. So if you go moving along this direction, the slope is y over x, change in y and over change in x. So that gives this formula, this line formula. Or you can think of in parametric curve, you can write down parametric curve, which is a little bit easier to understand, because if you look at this as your current point, x0, y0, and you are moving along gradient f direction, so after time t, you have, if you're going along gradient f direction, then the change in x is by the speed of f of x, and change in y is by the speed of fy. So y0 is current position of y plus t times the speed in y. This is t times speed in x. That gives the parametric form of the equation. This is parametric form of line. So it's better to get familiar with both things. I often see the people, students, are familiar with one form but not the other one. It's better to know these two are equivalent, as long as the denominator is not equal to 0. All right, what about tangent line? Tangent line is perpendicular to gradient f. So tangent line is perpendicular to gradient f, which means if I have a tangent line going through x0, y0, then we can take any xy here. So this vector is given by x minus x0, x minus x0, y minus y0, which is perpendicular to gradient f, which is fx, fy. Perpendicular means their dot product equals 0. If you calculate x minus x0 times fx, this is the first term, and these two gives second term. Add them together, which is dot product, and has to be 0 because they are perpendicular. All right, so I suggest when we look at the next example, we're not going to memorize any formula here. So as long as you know normal line is direction of gradient f, and and tangent line is perpendicular to the gradient f, then the whole thing is just straightforward. So let's look at this problem. So find an equation of tangent to the ellipse given by this implicit function at the point -2, 1. So pretending you are not in Calc 4, you're in Calc 1, then what is this problem? First, you want to know what kind of curve you have. So in this kind of curve is usually yield ellipses, and the standard form is following. You put 1, normalize the right hand side into 1, then this gives you standard form 2 squared of 2 square and plus y squared of 2 square equals 1. And this kind of equation typically gives you round shape, and this is 2 squared of 2, and you can x can go negative 2 squared of 2 at most, and this is squared of 2 and negative squared of 2, and the line or the curve is going to be this ellipse. And -2, 1 is the point we're interested in. So you're sitting at -2, 1 somewhere here, and we want to know what is tangent line. Find an equation of tangent line and find an equation of normal line. Okay. So by far, everything is in Calc 1 knowledge, but we're going to use Calc 2 knowledge to solve this problem. So we think of this ellipses as a level set of a valley given by x squared over 4 plus y squared. Then the curve is level set of this 3D surface at level 2. So for the normal line, it's just slope going, it has a slope the same as gradient. So we want to look at gradient z, which is zx, zy, and if you compute, this is x over 2 and 2y. And if you put -2, 1, which is the actual numbers, then this is -1 and 2. So this is the direction of normal line. If you normalize it, usually, strictly speaking, direction has to be normalized by its length. Now, what it means is normal line equation is the same as 2, -1. So this is the equation with the direction like along this. And I want to change y0, x0 by actual number here. This number is -2, 1, -2, 1. So I can use -2 is for x0, 1 is for y0. And we rearrange that, then this is y minus 1 equals -2x -4. And that simplifies to -2x plus a -3. So this is normal line. The tangent line is perpendicular to gradient z. In other words, if I multiply x minus -2 times fx, right? So the dot product So, and then y change times this 2. This has to be 0. And we simplify that. That gives me 2y minus 2. I'm doing the second term first, and first term is negative x negative 2 equals 0. So it is 2y minus x minus 4 equals 0. If you want, you can further simplify that to isolate y. All right, that's everything for today.